In this video, I just want to briefly discuss how ions differ from neutral molecules in terms of their number of valence electrons. So the number of valence electrons is affected by the charge on the ion. A negative charge, or an anion, indicates that there are extra electrons compared to what there would be if it were neutrally charged. So when you're adding up your total, when you're doing step 1 for your process, for drawing a Lewis structure, you want to add one additional valence electron to your total for each negative charge on the ion. A positive charge, or a cation, indicates that the structure is missing electrons compared to the neutral molecule, so you want to remove one valence electron from your total for each positive charge on the ion. So a couple quick examples here. The only thing that differs is step 1. Once you've got your total, you use it in exactly the same way. So for the first example, for NCl4+, nitrogen is in group 5, so it will have 5 valence electrons. Chlorine is in group 7, and there are 4 chlorine atoms, so we'll have 4 times 7. So this is from the nitrogen, 4 times 7 from the chlorine. And then because it's positively charged, that means that this ion has 1 fewer than that collection of atoms typically would. So we're subtracting 1 electron to accommodate that positive 1 charge. So 4 times 7 is 28, plus 5 is 33, minus 1 is 32. So this structure will have 32 electrons overall, and from there we can proceed as normal. Nitrogen is unique. It is the only unique atom, so it's going to be the central atom, and we can arrange everything else around it. The next step in our process is to fill up the peripheral atoms so that they have 8 valence electrons, which is going to be adding 3 lone pairs to each. So at this point, we can check and see how many valence electrons we have. We have 2, 4, 6, 8 around this chlorine. 8 here makes 16. 8 here makes 24. 8 here makes 32. So we have all 32 of our electrons accounted for. We just made sure that all of our chlorines have filled valence shells. Our nitrogen is involved in 4 bonds, each of which has 2 electrons, so it also has a filled valence shell. So this one is good to go. Pause here and try the next example, NO3-, the nitrate ion, on your own. So for this one, we'll do something very similar. Nitrogen is group 5, so it will have 5 electrons. Oxygen is in group 6, and there are 3 of them in this ion. And then that negative charge is telling us that we have an extra electron. So since it's -1, we're going to add 1 more. So 3 times 6 is 18, plus 5 is 23, plus 1 is 24. So we're looking to get to a total of 24. And again, the 5 is from the nitrogen. The 3 times 6 is from all of our oxygens, and this extra electron is from that -1 charge. Nitrogen is unique, so once again it will be central, and we can put our 3 oxygen atoms around it. Then we can fill up the valence shells with lone pairs. And now we are out of electrons. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we have placed all of our electrons, but nitrogen does not have a filled valence shell. It has 2 electrons in each of 3 bonds, which only gets it 6. So this is where we're going to want to take 1 lone pair off of any of our oxygens and move it to create a double bond. So we'll be moving this lone pair here and creating that double bond. So now nitrogen has a filled valence shell. It has 4 bonds, 1, 2, 3, and 4 with the double, each of which has 2 electrons for a total of 8, and we have the correct total number.